Hi everyone, I hope the exam went well. So let us discuss the chemistry 45 questions, right? So I'll read the question number 1. 1.2 gram of a sample of sodium chloride when treated with the excess of silver nitrate solution gave 2.870 gram silver chloride. The percentage purity of the sample is. Okay, so they are asking the percentage purity only, right? So how to find out the percentage purity of the sample? It means we can easily find out the percentage purity of the sample by taking this equation. So percentage purity is equal to of sample is equal to actual weight of the sample divided by given weight of the sample. Given weight of the sample into 100. So the numerator actual weight of the sample means we can find out through the equation only, right? So let us write the equation. NaCl plus AgNO3 giving NaNO3 plus AgCl, right? So I'm making a column NaCl and AgCl because the question paper says these two factors only, right? So what is the meaning of excess AgNO3? Excess means more than one reactant is there. Now there is a possibility for only one limiting reagent, right? It means this is the limiting reagent. Means the product depends on the limiting reagent only, right? So from the equation 58.5 AgCl will be 143.5 only, right? Then the given 2.870, we can find out the actual weight of the sample, right? So how to find out the actual weight of the sample? That is equal to 58.5 into 2.870 divided by 143.5 you will get, right? So the answer will be 1.17 only. So actual weight of the sample, now I got that. So I can put that value 1.17. But they are telling it is not fully NaCl. The given weight is 1.2 gram only, right? So the given weight of the sample will be 1.2 that into 100. So I will get, which is the answer? 97.5 is the correct answer. Thank you. Okay, let's discuss the question number 2. The atoms of F990 and Cl1735 are, right? So we are going to find out the relationship between these two only, right? So the first thing, that is the isodifer. Isodifer, for most of the students, it will be a new term. What is the meaning of isodifer? So when we find out the difference between, that is isodifer is actually difference between number of neutrons and number of protons. Same. So we are going to find out the difference between these two only, right? So from the F990, what is the number of protons? So number of proton will be 9. What is the number of neutrons? 19 minus 9, that is equal to 10. So what is the difference? 10 minus 9, that is equal to 1 only, right? So here also we can find out what is the number of protons? 17. What is the number of neutrons? Mass number minus atomic number, right? So it will be 18. So what is the difference? 18 minus 17 is equal to 1. So these two cases we are getting the same difference, right? That is known as what? Isodifer. Now we have to verify the remaining also. The remaining everything we know that isotones means same number of neutrons. Isoelectronic means same number of electrons. What is the meaning of isoester? Isoester is a new term also. For example, F2 and HCl, they are isoester only. F2 means what? How many atoms are there? 2. Here also how many atoms? 2. What is the total number of electrons? 9 plus 9, that is equal to 18. Here 1 plus 17, 18. That means, what is the meaning of isoester? Same number of atoms as well as total number of electrons are same. Thank you. Okay, let's discuss question number 3. The radiation of smallest wavelength in the Balmer series of helium ion is the same as that for. So they are telling the Balmer series only, right? So what is the value of N1 for Balmer series? That is equal to 2 only. And they are also telling the smallest wavelength only, right? So we know the relationship between wave number and wavelength. They are inversely proportional to each other only, right? So smallest wavelength means we have to get maximum this wave number, right? So in order to get the maximum wave number, this quantity, it has to be 0 only, right? That means N2 is equal to what only? Infinity only, right? So they are telling the helium only. So helium plus I can put. So nu bar is equal to Rydberg constant into what is the atomic number of helium? 2. 2 square will be 4, and thereby this will be 1 pi N2, that is N1 square. It will be also 4. So 4 into 4, you will get the RH. Correct? So we can go for the options there. So we can take the Lyman series of hydrogen atom, right? For Lyman series now, what is the value of N1? Lyman series now, N1 will be 1 only. So if I can put nu bar is equal to RH into proton atomic number 1 square will be 1 into 1 by 1 square. So again we are getting the RH only, right? For the smallest wavelength, both the cases we are getting the same RH value only. So the correct answer will be option C only. Thank you. Okay, let's discuss the question number 4. Which of the following is the correct order of increasing radii of ions, right? So we are given with these 4 only, right? Among these 4, these 3 are isoelectronic species only, right? For an isoelectronic species, means same number of electrons. Whenever the negative charge increases, size also increases. When the positive charge increases, size decreases, right? So first we can find out the correct order of these 3, right? So the correct answer will be N3 minus greater than or 2 minus greater than F minus, right? These are isoelectronic species only. But what about the phosphorus? Phosphorus atomic number we know that 15 plus 3 electrons, 18 electrons will be there. So definitely P3 minus will be at first, right? So P3 minus will be first. So we can verify which of the following option is matching. That is the correct option will be option D only, right? Okay, let's discuss the question number 5. For B2, B2 plus, B2 minus, the correct order of increasing of bond order, right? So bond order we can easily find out the bond order. If the total number of electrons 14, bond order will be 3. If 13, 2.5, 12, 2. Here also we can count like that. 15, 2.5, 16, 2, like that you can go. So here 11, 1.5, 10, 1, 9, 0.5, 8, 0. Like here also you can continue, right? So you take the B2. What is the total number of electrons? 10. B2 plus 9. B2 minus 11. So 11 1.5. 9 electrons 0.5. 10 electrons 1. So the correct answer will be B2 minus, then B2, then B2 plus. So this is the correct answer. So which option is matching? Option C only matching. Thank you. Okay, let's discuss the question number 6. The structure and hybridization of ICl2 minus only, right? So we know how to find out the hybridization very fast, right? That is valence electrons of central atom, right? Valence electrons of central atom plus number of monovalent atoms, right? Plus anionic charge minus cationic charge all divided by 2, right? So here, which is the central atom, least repetition, iodine only. So valence electrons of iodine will be 7. Chlorine is a monovalent, but oxygen if there are you cannot take because oxygen is a divalent only. So chlorine I can take, so 7 plus 2. If anionic charge minus I have to add. So it will be plus 1 divided by 2. So 7 plus 9, 10 by 2, that is equal to 5. 5 sp3d only. So hybridization will be sp3d. What is the meaning of this 5? The central atom has to be surrounded by 5 atoms. But here we have only 2 chlorine atoms only. So 3 lone pairs will be there. That means sp3d with 3 lone pair of electrons now, shape will be linear. So the correct answer will be sp3d and linear shape. Thank you. Let's discuss the question number 7. The dipole moment of a bond AB is 5 dBA and its bond distance is 150 picometer. The percentage ionic character of this bond is. So we know that the percentage ionic character is equal to dipole moment in ESU angstrom into 100 divided by dipole moment of a pure ionic bond in ESU angstrom. Generally, we forget this ESU angstrom. So do not forget that ESU angstrom unit also. Be careful. So we know that this dipole moment of a pure ionic bond in ESU means what? That is the E0. That is the charge of electron. That is 4.8 into 10 raised to minus 10 into bond length. Then we can find out the dipole moment of a pure ionic bond, right? So that is 150. It is in picometer. So we can convert into angstrom. That is multiplied by 10 raised to minus 2 only, right? Now, what is the dipole moment in ESU angstrom? We are given with the 5 dB only. So 5 into 10 raised to minus 10 ESU angstrom, because 1 ESU angstrom is equal to 10 raised to 10 dB only. So I am converting dB into ESU angstrom. So I can cancel these two and I can find out the answer. So the correct answer will be 69.5. So this is the correct answer. Thank you. Okay, let's discuss the question number 8. Two cylinders A and B contain the same gas at same temperature. The pressure and volume of A are both twice those of B. Then the ratio of the number of molecules of A and B. So we have one equation there, ideal gas equation. PV is equal to NR. So once we get the number of moles value same, we can find out the number of molecules also. The ratio only, so there is no need to convert the number of molecules. We can find out easily the number of moles relation only, right? Suppose B, I am taking the value of pressure PB and the value of volume VB. Then what about the A they are telling? They are telling the pressure of A twice only, right? So for A it is PB, here also it is 2 VB only, right? So when I find out the N value, so N is equal to PV divided by RT only, right? So let me find out the value of Na divided by NP. So N A I can put 2 PB into 2 VB, that divided by PB and VB, right? So the ratio will be 4 by 1, that is equal to 4:1 only. So this is the correct answer, right? Thank you. Okay, let's discuss the question number 9. Average bond enthalpies of HH, ClCl and HCl are 435, 243 and 431 kilojoule per mole respectively, right? So that is very important, per mole. So you always write the equation according to get 1 mole of the product, right? So half H2 plus half Cl2, I will get 1 mole of HCl. In terms of bond energy they are asking. So we know the equation, delta H formation is equal to, in terms of bond energy, the sigma reactant minus product only. So let me do that. So half into, what is the H2 value given? That is 435 plus half into 243, right? So this minus half into, what is the product value there? We are given with 431. So I will get the answer as minus 92 kilojoule per mole. So this is the correct answer. Thank you. Let's discuss the question number 10. Under identical conditions, how many ml of 1 molar KOH and 1 molar H2SO4 solutions, when mixed for a total volume of 100 ml, produce the highest rising temperature? That is enthalpy of neutralization in thermodynamics we have to apply, right? So when 1 mole of H plus is exactly neutralized by 1 mole of OH minus, both are strong acids as well as bases. For a strong acid and strong base only, we can apply this. That is, the value will be minus 57.3 kilojoule per mole only. So when for a strong acid and strong base, 1 mole of H plus is neutralized by 1 mole of OH minus, the answer will be minus 57.3 only. Now let me do that. For example, the first mixing, 50 ml of KOH and 50 ml of H2SO4, right? So for 50 ml of KOH now, molarity is given as 1 molar only, right? So left side I can put 1. So 1 is equal to number of moles of KOH. Number of moles of KOH, that divided by volume in liter. That means 0.05 only, right? So number of moles of KOH will be 0.05. right? Similarly, I can apply the same thing on the H2SO4 also. So 1 is equal to number of moles of H2SO4 that divided by volume in liter, that is equal to 0.05. So I will get the exact same value, number of moles of H2SO4 is equal to 0.05. But don't forget that if I take 1 mole of H2SO4, it will produce 2 moles of H plus only, right? So 0.05 moles of H2SO4 I take now 0.05. So number of moles of H plus will be 2 into 0.05 only. Correct? Because double the number. Because 1 mole of H2SO4 will produce 2 moles of H plus only. Now, which is the limiting factor? So this is a large quantity, this is the smallest quantity, right? So smallest quantity will determine the factor there, right? Similarly, you can find out there is each option. So the correct answer they are telling the C only. I will prove that. So what is the value? So number of moles of KOH. Number of moles of KOH will be equal to molarity is 1. So that into 0.067. That is the number of moles of KOH, right? This equation we can apply. And what about the 33 ml of H2SO4? That is the number of moles of H2SO4 is equal to same way molarity 1. Here I don't know value. Here I know the value 33. So that will be 1 into 0.33. 0.033, right? So that means, but what about the number of moles of H plus? Number of moles of H plus now double the number, right? 0.033 plus 0.033, right? So 0.066, correct? So which is the limiting factor? 0.06 is a limiting factor. This is 0.067, right? So here you are getting the maximum number of moles of OH minus and H plus compared to the remaining 3 options. So here the liberation of heat will be very high. So how we can find out the liberation also? 1 mole now it will be 57.3. Then we can find out 0.066. What is the value in kilojoule? That value also we can find out. They are not asking the value where we are getting the maximum heat liberation only. So the correct answer will be C only, the correct answer. Thank you. Okay, let's discuss the question number 11. The yield of product in the reaction A2 gaseous plus 2B gaseous equilibrium C gaseous plus Q. Plus Q means heat is liberated only, right? So that is an exothermic reaction only. So we can underline that is an exothermic reaction only, right? They are asking the yield maximum only, right? We know that. For an exothermic reaction now, the temperature has to be very low only for maximum yield, right? So we know that low temperature we can mark. And what about the pressure? So we know that to get the maximum yield, what about the number of moles on the left side? 2 plus 1, 3. What about on the right side? 1 plus 1 only. So 3, this is not 1 mole because Q is heat only, not the number of moles, right? So left side 3, right side 1. So when we increase the pressure according to Le Chatelier principle, it will be shifted towards the right side, right? So more yield we will get, right? So high pressure. This topic is based on which portion? Le Chatelier principle. So this is the correct answer. Low temperature and high pressure favors the maximum yield of the product. Thank you. So let's start the question number 12. The Ka value of acetic acid and formic acid are given to be 1.78 into 10 raised to minus 5 and 1.7 into 10 raised to minus 4 respectively at 298 Kelvin. The ratio of acid strength of 0.1 molar formic acid and 0.1 molar acetic acid. So this is separate. Look at here. Strength they are asking. Means strength comparison they are asking now. Strength of acid A divided by strength of acid B will be exactly equal to square root of Ka into Cv. A means this acid A, dissociation constant of A divided by its concentration into Kb means dissociation constant of acid B. Here the concentration of B only. So here what they are asking, strength of formic acid divided by strength of acetic acid. So we know that the equation. What is the formic acid Ka value? We are given with the Ka value 1.7 into 10 raised to minus 4 divided by concentration, both cases it is equal. So 0.1. What about the dissociation constant of this acetic acid? Acetic acid is 1.78 into 10 raised to minus 5. Here also the concentration is 0.1, right? So after that we can do the remaining steps. The final answer will be 3.16. So this is the correct answer. Thank you. Okay, let's discuss the question number 13. Regarding Fe4, FeCN6 whole twice, which is not a correct statement, right? So this is a coordination compound actually, but this topic is from basic concepts of, that is basic organic only. So we can apply that, right? So what is the name of this compound? According to IUPAC rules, the name will be iron hexacyanuro-ferrate 2 only. But simply we can call it as what? Ferric ferrocyanide, right? So let me do that. The possible oxidation state of iron are, we know that, the +2 and +3 only, right? And one more thing there, whatever the overall charge on this complex, it has to be exactly neutralized by this charge only, right? So you can put what are the possibilities here, you can put that. So let me take one example here. Suppose this iron is +3 now, +3 into 4, it becomes +12 only, right? So this has to be -12 only. So cyanide charge, we know that -1. So -1 into 6, it will be -6. Suppose this iron I am taking as +2. So this is +2. So +2 minus 6, that is -4. -4 into 3, I am exactly getting the -12. You can put the other possibilities also, like here you can put +2, here you can put +3, whatever the values, it will never match. This is the only one possibility there, right? Now it means overall we have 7 iron atoms are there, 4 outside and 3 inside. These 4 Fe, that is outside, are in which oxidation state only? +3. The inside 3 iron atoms are in actually which oxidation state only? +2 only, right? So now you can verify the options. So which option is incorrect? Which is not a correct statement they are asking. It means incorrect they are asking, right? So which is the correct one? So the overall charge will be +12. Here will be +6. So overall will be +18. So average oxidation state will be 18/7 only, right? But you look at the option number 4, they are telling that it is 5/4. So definitely that is an incorrect statement only. You can also verify the remaining, whatever I told you, you can verify that. Thank you. Okay, let's discuss the question number 14. 10 ml of a sample of H2O2 gave 1000 ml of O2 at STP. The sample is. Now we know that 10 volume H2O2 is, what is the meaning of that 10 volume H2O2? 1 ml of H2O2 will produce 10 ml of O2 at STP. It means then if I go for 10 ml now, 10 ml of H2O2 now, definitely it will be giving 100 ml only, right? So that is not the answer, because they are telling that 10 ml it has to produce the 1000 ml only, right? So this is in the NCERT textbook only. So what is the meaning of 100 volume H2O2? So 100 volume H2O2 means 1 ml of H2O2 will give, instead of 10 or 10 ml, this is 100 now, this is 100 ml of O2 at STP, correct? So instead of 1 ml, if I go for 10 ml, it becomes, yes, exactly, I will get 1000 ml of O2. So which is the correct answer? So the correct answer will be 100 volume of H2O2 only. Thank you. Okay, let's discuss the question number 15. Lowest ionic mobility among hydrated alkali metal ions is possessed by. We know that whenever the size of the ion is small, its hydration enthalpy will be very high. So according to the hydration enthalpy point, lithium plus will form complex with the water molecules here, right? And thereby, so maximum tendency for water will be for lithium plus only. And thereby it becomes a bigger complex. So if hydration enthalpy is more, there is a more tendency for water. And thereby lithium plus become a large complex. So which is having less tendency for water, that is the Rb plus only, right? So its mobility will be fast. They are asking what? lowest ionic mobility only. So lowest ionic mobility means it will have a large tendency for water and thereby it becomes a huge complex. So its mobility will be very, very less. So the correct answer will be lithium plus only. Thank you. Okay, let's discuss the question number 16. Which among the following statements regarding the structure of diborane is incorrect, right? So that is an NCERT textbook question only. We know the diborane structure there. We have 2 banana bonds are there and 4 terminal boron hydrogen bonds are there, right? So these four terminal bonds are actually 2 center 2 electron bonds only. But what about the 2 banana bonds? They are 3 center 2 electron bond only. So from the option, it is very clear that the incorrect statement will be definitely option A, and you can verify why the remaining 3 options are correct. So that also we can study. That means 4 terminal hydrogens are there in same plane, and these 2 banana bonds, one is above the plane, one is below the plane, right? So the incorrect statement definitely will be option D only. Thank you. Okay, let's discuss the question number 17. Fog is an example of a colloid in which we know that is from surface chemistry only. We have a table there. That table with the examples, everything is very, very important. As we know that fog is under the category of aerosol only. That is the dispersed medium is gas only. Dispersed phase is liquid only. That means liquid in gas only. That is known as aerosol. The remaining examples are FMC. That is fog there, mist there, cloud there. So which is the correct option? Liquid dispersed in gas is the correct answer. That belongs to aerosol. Thank you. Okay, let's discuss the question number 18. The relation A not equal to B not equal to C for edge length and alpha is equal to gamma is equal to 90 degree, beta not equal to 90 degree. For axial angles is characteristic of which crystal system? That is from solid state only. We know that we have 7 basic crystal systems are there. We have one chart there. The chart with the example also very, very important. So this value, this is axial distance. This is or edge length, we can call it as these are axial angles there, right? So which is the correct answer? That is the monoclinic will be the correct answer. For a monoclinic system, A not equal to B not equal to C, alpha is equal to gamma 90 degree, beta not equal to 90 degree. What about the example? Monoclinic sulfur is one of the examples of that category, right? Thank you. Okay, let's discuss the question number 19. Which of the following compounds contain sp hybridized carbon atoms? So I will give the trick how to find out the sp hybridized very easily. So sp na first one triply bonded carbons. Triply bonded carbon. One more is there, a carbon with both sides double bond. So this star marker carbon also will be sp only. So that is the answer. So we can verify that here now. This is sp2, sp2, this is sp2, this is also sp2 only. So when a double bond and single bond, priority you have to give for double bond only, right? So the double bond, this carbon you have to consider as the double bond, that is sp2 only. Now what about this carbon of the carbon? Both sides double bond there, right? So sp hybridized carbon there. Now when we split the cyanide as C triple bond N, this carbon is which hybridized only? sp hybridized only. What about this carbon? This carbon also both sides double bond there. So this is also sp hybridized only, right? So which of the following that is the correct answer? So we know that second, third, fourth. So the correct option will be second only. Thank you. Okay, let's discuss the question number 20. The violet colored complex obtained during the test for sulfur by adding sodium nitroprusside. This is from basic organic chapter, that is the second part only, qualitative and quantitative analysis, right? So we know that for the confirmatory test of sulfur, when we add sodium nitroprusside, what is sodium nitroprusside? Na2FeCN 5 times NO. So sometimes they will ask what is the oxidation state of iron, like that also they will ask. This is +1, this is -1, so -1 into 5 minus 5 +1. +1 into 2 +2. So this has to be -2 only. So you can find out the oxidation state of iron also. This is +2 only. So when an organic compound containing sulfur I add now, the sulfur will be inserted inside that is the complex. So I will insert the sulfur CN 5 times NO Yes, thio group will be inside, that is sulfur, right? So we know that sulfur charge will be -2. So the overall charge will be -4 only, right? -2 already there, -2. So -4. So this has to be to neutralize that Na4 only, then it becomes +4. Now look at which of the following option is correct only. So the correct option will be option D only. Thank you. Okay, now let's discuss the question number 21, right? It is not possible to isolate staggered conformation of ethane from eclipsed conformation of because. Now, which chapter? Hydrocarbon chapter. From which portion? That is the conformations, right? The free rotation will be there. So we know that during the conformations, bond angle will not change, bond length will not change, only dihedral angle only changes. But isolation of these conformation will be very difficult. Why? Because the energy difference is very small. So one form will be converted to other form. The stability also, sometimes they will ask that. If they are asking stability now, what is the correct order? If intramolecular hydrogen bonding is there now, partially staggered first, then fully staggered, then partially eclipsed, least will be fully eclipsed. But if there is no intramolecular hydrogen bonding, which is the correct answer, it will be, first will be fully staggered or anti, then partially staggered or Gaussian form, then partially eclipsed, least will be fully eclipsed. Here they are asking, the isolation is very difficult. So which is the correct answer? One form will be converted to other. So what is the answer? So the correct answer will be option B only. Thank you. Okay, let's discuss the question number 22. Which of the following has the lowest heat of hydrogenation, right? Hydrocarbon portion only. So we know that heat of hydrogenation is inversely proportional to stability, right? So once we find out the stability of alkene, you take the reverse of that. That will be the answer, right? Then the stability of alkene will depend on which factor? Hyperconjugation you can go. So hyperconjugation will depend on number of alpha hydrogen atoms only, right? Now if hyperconjugation is same, but one is cis form, other is trans now, trans form will be more stable. So now, for example, I will take the first one, but 1E. So if I take this is the but 1E, 1, 2, 3, 4. So this is my reference. So this is alpha carbon. There are two alpha hydrogens are there. So two hyperconjugated structures are possible there. Like that you can find out that. Now the cis form and trans form. For example, I will get one more. That is the option number but 2E. If I take CH3, CH double bond, CH, CH3. This is 1, 2, 3, 4. But 2E. So this is my reference. So this is alpha, this is alpha. So 3 plus 3, that is 6 alpha hydrogens are there. So 6 hyperconjugated structures are possible there. So trans form and cis form, you know that this CH3 and this CH3 opposite trans. So cis and trans both will be having same number of alpha hydrogen, but which is more stable? Trans butane will be more stable. So more stable in a heat of hydrogenation will be least only. So the correct answer will be trans butane only. Thank you. Okay, let's discuss the question number 23. They're asking which among the following is not aromatic, right? So we have three species there: aromatic, anti-aromatic, and non-aromatic. Actually, aromatic and anti-aromatic one category, non-aromatic other category only. So how to distinguish between these two? Aromatic, anti-aromatic means that the minimum conditions will be it has to be cyclic, planar. Second condition will be complete delocalization of electrons. If these two are not valid, then it will go for the non-aromatic category only. Then between these two, we can go for Huckel's rule. 4n plus 2 rule, pi electrons are there, or delocalized electrons are there now. We know that it is aromatic. 4n rule now, it will be anti-aromatic only, right? So these pictures, we know that all are having complete delocalization there, small structures only, and cyclic. So cyclic, planar, and delocalizations there, right? So oxygen is there only. So for delocalization purpose, this lone pair also we can count. So 2 plus 2, 4 plus 2, 6 electrons are there. That is 4n plus 2 only. Here, that is one positive charge also there. So positive and pi bond both are in conjugation. So here it will be 2 electrons. So here also 4n plus 2. Propylene carbocation. Here also 2 plus 2 plus 6 electrons. So here also 4n plus 2. But what about this case? Cyclic planar delocalization there. But we know that here 4 electrons only. So it follows 4n rule only. That means it is anti-aromatic only. What about the stability order? If they are asking the stability order now, first will be aromatic, then will be non-aromatic, least will be anti-aromatic. Thank you. Okay, let's discuss the question number 24. Identify A, B and C in the following sequence of reaction. They are telling that you can take each options. Finally, we have to get the methyl only. So let me take the first option. What is methyl chloride? CH3Cl only, right? KCl if I treat now, it will be CH3Cl. That on hydrolysis, here you have to make a note there. If they are asking partial hydrolysis now, Cn will be converted to amide. They are not telling any hydrolysis, means simple hydrolysis only. So Cn will be converted to COH. So CH3COOH only. Soda lime, that is calcium oxide plus NaOH, right? Quick plus NaOH. So what is the purpose of soda lime? Soda lime purpose means removal of carbon dioxide from an acid, right? So here the carbon dioxide will be removed and thereby I will be getting the CH4. Yes, I will get the CH4. So definitely the answer will be option A. And you can also verify why the remaining options are not at all correct. Thank you. Okay, let's discuss the question number 25, right? The decreasing order of ease of dehydration of the following alcohols. So dehydration, we have to go for the stability of carbocation only, right? So we know that the stability of carbocation, the complete order also we have to study. Mainly resonating effect will be there. After that, what plus effect also the key factor there, right? So here I know that after the removal of the OH, I will get the positive charge here only. Here after the OH, here I will get the positive charge, and here I will get the positive charge, and finally here I will get the positive charge, right? Now you verify that among these four, which is the highest stable carbocation, definitely this only, right? Because it is surrounded by two CH3 group as well as resonating effect also possible there. After that, here also one resonating effect is possible there as well as plus effect also there. So first will be here, second will be here, and what about this one? Secondary and primary. We know the stability, definitely secondary only. So third will be here, and this is the stability order. So first this is third greater than first greater than second greater than fourth. So that will be the correct answer. Thank you. Okay, let's discuss the question number 26. The correct increasing order of acid strength they are asked, right? So we know that the phenol is the reference. We are putting two types of groups there. First one is NO2. They are electron withdrawing only. So acidic character of phenol is directly proportional to electron withdrawing group, and acidic character of phenol is inversely proportional to electron donating group, right? So we know that this is electron donating group only. So definitely it will be least only. So 1, 2, 3, 4, 5. So 5, I know that. Then differently it will be fourth one only. And among these three, all are having the NO2 group only, right? Now we can directly go for the stability of phenoxide there. So NO2 group is an electron withdrawing group only. So whenever phenol donates one H plus, phenoxide will be formed, and phenoxide and stability will be enhanced by the presence of NO2 group. So when we draw the resonating structure of phenoxide, we know that the negative charge will be on ortho and para only. So when we put the electron withdrawing group on ortho and para, the stability will be enhanced. So ortho and para, definitely competition will be there. So definitely I can write this will be there only, right? Then the competition starts between this and this. But we have to consider the intramolecular hydrogen bonding here. This hydrogen can take part in intramolecular hydrogen bonding because this is connected to an electronegative element as well as there is another electronegative element like oxygen there. So there is a hindrance will be there, that is the intramolecular hydrogen bonding. So whenever the competition starts, who will win that? Definitely para will win. So this will be first one, this will be second one. So this is the correct answer. Thank you. Okay, let's discuss the question number 27. So we have, this is the question, right? So this is the acid functional group only. So we know that when we use diborane tetrahydrofuran followed by water, as well as lithium aluminum nitrate followed by water. If we use these two reagents now, this COH group will be converted to CH2OH only, alcohol. But if I use dibal now, COH will be converted to CHO only. So this A will be CH3, CH2, CH2OH will be there, right? Now, to that I am using the SOCl2 only, right? So SOCl2 purpose will be what? This OH group will be replaced by chlorine. So what is the answer of B? It will be CH3, CH2, CH2, Cl only, right? Now after that I am using the KCl now. Cl will be replaced by Cn. So I will get CH3, CH2, Cn. I will get that on hydrolysis they are asking in presence of an acid. Cn group will be converted to COH. So CH3, CH2, CH2, COH will be the correct answer. So which is the correct answer? Option D is the correct answer. Thank you. So let's discuss the question number 28. Correct increasing order of boiling point only, right? So boiling point, when they ask boiling point, the first parameter we have to remember is the molecular mass. That is why the question paper says that comparable molecular mass only we can apply this. So first priority for molecular mass. Then we can go for the hydrogen bonding only. So the common functional groups are acids, alcohols, everything like that, right? So between acid and amines, alcohol if you take now, generally we know that the answer, the first will be COH, molecular mass, comparable molecular mass. Then it will be OH, strength of hydrogen bonding. Then it will be amine. Then what about the aldehydes and ketones? They both having carbonyl compound there, right? So there is no possibility for hydrogen bonding there. But we know that the polarity factor will be greater for ketone only. Then only aldehyde comes. Then we can go for ether. The least will be normal alkane. Correct? So, comparable molecular mass, this is the boiling point order. So, we can compare that. The first, there is no acid group there. So, this will be first one. Then, this will be the second one. This will be the third one. And this will be the least one. Correct? So, that is the boiling point order. Thank you. Okay, let's discuss the question number 29. That is very important question. A substance C4H10O yields on oxidation a compound C4H8O which gives an oxime and a positive iodophone test. The original substance on treatment with concentrated H2SO4 gives C4H8, the structure of the compound. For these type of questions, we have to start from the option. So suppose I am taking the D option, I will verify that why the D option is correct. So CH3, CHOH, CH2, CH3 if I take now, that they are asking the oxidation only. So I will get CH3, CHOH will be oxidized to give C double bond O, CH2, CH3, right? So definitely it will undergo iodophone test because CH3, C double bond O group is there. So CH3, C double bond O group is there now on iodophone test, that is NaOH plus I2 or sodium hypoiodide now. This will be converted to CH3 will be converted to CHI3. This part will be converted to sodium salt, right? So CH3, CH2, COONA. So definitely it will undergo iodophone test. Then one more thing they are telling that this species, this is the original substance, I am treating with concentrated H2SO4 now. Dehydration will happen. H plus will attack and it becomes OH2 plus. Simply I am putting like this only, right? So I will be getting a carbocation like CH3, CH plus, CH2, CH3. Now this is alpha, but according to Seiser's rule, non-terminal alkenes will be more stable. So definitely I will get this hydrogen will be removed as H plus and thereby I will get this one, right? So what is the molecular formula? This becomes C4. How many hydrogens are there? C4H8, correct? So everything is matching. So I can run, this is the correct answer. You can also verify why the remaining 3 options are not at all correct. You can verify that. Thank you. Okay, let's discuss the question number 30. The compounds that give foul smelling isocyanate when warmed with chloroform and ethanolic potassium hydroxide are. We know that that is from amines chapter only, which portion carbylamine reaction. So what is the condition for carbonyl reaction? System has to possess primary amine group only, right? So primary amine, that is the NH2 group. So you can verify among these four where we are getting the NH2 group. So NH2 group is there now, it will be converted to NC. That is having the foul spelling. So here one is there, here one is there, right? So where are we getting? That is the second and third cases we are getting the primary amines, right? So the correct option will be option B. Thank you. Okay, let's discuss the question number 31. The configuration of which carbon atom of an aldohexose is compared with the configuration of the chiral carbon atom of glyceraldehyde to assign D or L configuration there, right? So what is this? D doesn't indicate dextro and capital L doesn't indicate the LEVO. These D and L are different only, right? This is actually, we know the glyceraldehyde, right? So the glyceraldehyde, this char marked carbon, if this OH group is on the right side, we know that the capital D. If this OH group is on the left side, we know that it is capital L. So I will write an example of aldohexose. Glucose is an aldohexose only, right? So I will write one of the examples of this aldohexose D glucose there, right? So actually, if in order to write this D, I have to go for this char marked carbon only. That is the carbon number 5. For example, aldohexose now, this is the CH2OH. The carbon which is connected to the CH2OH like this. This is the carbon connected to the CH2OH. So I can put a box there. So in order to call it as a capital D, this OH group has to be on the right side. It means for an aldohexose, which carbon atom? The carbon number 5. It doesn't say anything regarding the remaining positions of the OH group on each carbon atom. No. It only indicates the capital D na this fifth carbon, that is the OH group, it has to be on the right side. Thank you. Okay, let's start the question number 32. So what they are asking, nylon 66 is a polymer of hexamethylene polymer chapter only. Actually that 66 indicating the number of carbon atoms in the monomer. So that is a trait. So first 6 is actually for hexamethylene diamine only. We know that the next monomer is adipic acid only, COH. CH2 4 times COH only, and after the polymerization we will get nylon 66 only, right? Thank you. Okay, let's discuss the question number 33. The sweetest compound among the following is, that is a large chapter there, chemistry in everyday life. So they will ask the power of that sweet, artificial sweetener, power also they will ask. So I will write the power order there. How many times also NCERT book is telling, that also you have to study for the exam, right? So the correct order will be allyl. Then it is the, in NCERT textbook, this is the sweetest artificial reagent, right? Agent there. Then after that sucralose, then saccharin, then will be the aspartate. So which is the correct answer? That is the allyl will be the correct answer according to your options. Thank you. Okay, let's discuss the question number 34. A complex is prepared by mixing COCl3 and NH3. A 0.1 molar solution of this complex freezes at minus 0.372 degrees Celsius. Molar depression constant of water is 1.86 Kelvin per mole. The formula of the complex is they are asking. So it is a mixture of coordination compound and solution chapter only. So we have an equation according to the solution chapter, delta TF is equal to I into KF into M, right? What is the delta TF they are giving? Delta TF is equal to 0.372. Do not convert to Kelvin because that is the difference only. So degree Celsius or Kelvin, whatever the given value, that value we can put here. So we know that the I value, I don't know. The KF is given as 1.86. Molarity is given as 0.1. Correct? So we can find out the I value. I is equal to 0.372 divided by 1.86 into 0.1. Correct? So the I value will be, I will get 2 is my I value there. So I can take each options there. For example, first I will take this value CONS3 5 times Cl and Cl2. That on ionization I will get CONS3 5 times Cl plus 2 Cl minus. So here for complete dissociation I value will be 3 only I will get. So that is not the answer. The second option you can take and third option you can take. Suppose I am taking the third option now. That will be the correct answer. I will prove that CONS3 if I take CONS3 4 times Cl2 and one chloride is outside. Now, after the ionization, I will get CONH3 4 times Cl2 plus 1 Cl minus there, right? So I value will be after dissociation 2, initially 1, so 2 by 1, 2. So definitely I will get, and that is the correct answer. Thank you. Okay, let's discuss the question number 35. The metal ion M N plus C is equal to 24 in a compound has a spin-only magnetic moment of root to 15 Bohr magneton. The number of unpaired electrons and oxidation state of the metal ion are respectively. So you have to study all the electronic configuration of 3D, 4D, 5D as well as lanthanums and actinoids there, right? So Z is equal to 24 means the element is chromium only. So chromium now, that is the electronic configuration will be due to half-field stabilization 3D 5 4s 1 only, right? So if chromium 3 plus I am taking now, what about the electronic configuration? 1 from here and 3D 3 4s 0. So the unpaired electrons will be 3 only. You know that you can draw like this D, right? So this is 3D 1 1 1. So 3 unpaired electrons are there. So spin magnetic moment equation also we know that spin magnetic moment root of n into n plus 2 only, right? But do not waste your time. I will give a trick there. So whatever the number of unpaired electrons, the answer will be next digit, closer to the next digit. For example, the answer is 3 now. Unpaired electron is 3 now. The answer will be next digit will be 4. So root is 16. Closer to that. Root 16 will not be the answer. Closer to that. For example, the unpaired electron is 5 now. Do not write root of n into n plus 2 and putting the value of 5. No. The next digit is 6 only. So the answer will be not root 36, the value closer to the root 36. So the correct answer will be the oxidation state is plus 3 only. So if the oxidation state is plus 3 now, we will get 3 unpaired electrons there, right? So what they are asking, so the number of unpaired electrons will be 3 and the oxidation number will be plus 3 and the final answer, the Bohr magneton will be root 15 Bm, Bohr magneton. Thank you. Okay, let's discuss the question number 36. For D4 ion, the electronic configuration of the D level when delta O is less than the pairing energy is there, right? So delta O means octahedral field only, right? So octahedral field, we have two sets of d orbitals there, T2G and EG. And one more thing is that do not put the G for tetrahedral complex. G indicates the Gerard symmetry only. So tetrahedral field doesn't have the Gerard symmetry there, right? So that was very important. And one more thing is there, that also you can note there. In octahedral field, two possibilities are there. These are the two possibilities there. When strong field ligand, this is the condition, and for weak field ligand, this is the condition there. But don't forget that for a tetrahedral complex, that is TD, there is no low spin complex. It means delta T is always less than pairing end. That is also very, very important. Pairing end for tetrahedral complex. Okay. Now we are asking the octahedral field only. So delta O is small there. So 1, 1, 1. Whether the ligand is strong or weak, we have to write 1, 1, 1 only. Then the fourth electron, according to the condition, they are telling delta O is less. It means which ligand only? Weak field ligand only. So the fourth electron goes here. Therefore, T2G 3 and EG 1. So which is the correct option? Option A. Thank you. Let's discuss the question number 37. So we are given with these two pairs here, right? They are asking the isomeric relationship, right? So this is known as what? Ionization isomerism. That is the exchange of anionic ligand between ionization sphere and the coordination sphere, right? So you can feel that one Br comes here, SO4 goes out there, right? So this is known as what? Ionization isomerism. Now here, what about this is known as solvate isomerism. Specifically here the solvent is water only. So you can call it as also hydrate isomerism also, right? So here you can feel that 3 chloride outside, 6 aqua inside only. But here now one H2O takes inside and one that is the chlorine also takes inside, and the remaining Cl2 dot H2O. So that is known as what? Solvate isomerism, specifically hydride isomerism. The exchange of anionic ligand between ionization and coordination sphere, that is known as what? Ionization isomerism. Thank you. Okay, let's discuss the question number 38. The refining method, which makes use of the principle that the impurities are more soluble in the lead than in the solid state of the metal. That is from the metallurgy chapter. So we know that there are several refining methods, modes there, as well as that this method, that is salt refining, is there, distillation, liquefaction, everything is there. So we have to read that, as well as the core portion is the examples only. So this answer, everyone knows that, that is a fact only, that is salt refining. What are the examples there? Silicon, germanium, those are the examples of salt refining. Van Arkel process, Moens process, everything you have to study with the examples. Thank you. Okay, let's discuss the question number 39. The strongest reducing agent among the following is, this is nitrogen family only, that is a P block chapter. Everything is very, very important, reducing property there, as well as the stability order also there. That is when we are heating, the stability order, everything is very, very important. So we know that from top to bottom there now, that is the reducing property, that is the reducing agent property increases there. So this is the order. So the reducing property order will be, this is the answer. So reducing property. So the correct answer will be B and S3. Thank you. Okay, let's discuss the question number 40. The strength of the conjugate bases formed from the oxo acids of chlorine increases in the order. This is a very important topic. These are the oxo acids of chlorine, right? What about this one? Hypochlorous acid, chlorous acid, chloric acid, perchloric acid, right? So what about the strength of acids? We know that perchloric acid is the strongest acid among these four, right? And according to the equilibrium, this is actually from B block only, but according to the equilibrium also, we know that if the acid is strong enough, its conjugate base will be weak only, right? So this is the strongest acid, that is strength of acid like this only. So this conjugate base will be the weakest one. Correct? This is a weak acid, so this conjugate base will be the strongest one. Correct? So we can make the correct order. That is, the correct order will be, which is the correct answer? So ClO minus greater than, ClO2 minus greater than, ClO3 minus greater than, ClO4 minus. So the correct answer will be option C only. Thank you.